Hello, hi, and welcome to the very first lesson at Be the Best Mathematics. My name is Anashe Siziba, and I'm also known as AJ Caesar. And I believe that if we are going to master this subject, we need to begin with what I consider a single most important concept in all the mathematics stuff that we know, which is the function.
So we are going to get into function. Now, a function is a rule. It is being defined as a rule that maps a number onto another number. So we have a single number mapped onto another single number. And when it is mapped onto another single number, this is not just done for any value, but it is done for a specific set of input values. That's what we call a function. Think of a function as a machine. You have the set of values that you put. You have certain inputs that you put into a machine. The machine does the work, it does the processes, and then you get the outputs. That's what happens to a function. But you don't just put any input into a machine. If let's take for example, if that machine is going to be a car, you put fuel, a specific type of fuel. If it's diesel, if it's petrol, you put a specific type of fuel. You don't just put any fuel into it. Same applies. We put a specific set of inputs into a function that works with the function. Certain inputs are not valid for certain functions. We put a specific set of input numbers that can be taken by the function. This specific set of input numbers is what we call the domain. And we also get the outputs. And the outputs that we get are not just all the outputs necessarily, but we get specific outputs that depend on our domain. Which means that when we have a specific domain, we get specific outputs, and these outputs are what we call the range of the function. So here we have a function, f of x is equal to x plus 1. So this function, explaining what the definition was saying, a function is a rule, and in this rule we are going to take x, whatever the number, in this case it is unknown, whatever the value of this unknown is going to be, we are going to put it into the function f, and this function is going to map it onto x plus 1. So it's like this machine that we have adds 1 to everything that we put into it. So here, this function adds is a function that adds 1. In other words, it takes x and it maps on x to x plus 1. This is also another notation that we can use. F is such that x is mapped onto x plus 1. So that's another notation that you may consider to use as well. Now, this set of values that are here are a set of values that are valid for the x that we put into the function f. So here, this is what we call the domain. In other words, x is put into f only if x is an element of real numbers and or if x is in between 2 and 4. Now, just taking possible, I'll just take the integers part. Now, here we're going to be having, let's say, 2, 3, and 4. All these numbers are numbers that are valid to be input into the function f. Now, when we put them into the function f, which is the function f is going to add 1 to each and every one of these values. So what are we going to get? We're going to end up having 3, 4, and 5. And these are going to be outputs. So these were inputs, and these are outputs. Now, the inputs, according to the explanation, according to the definition, according to what I'm saying, the inputs that we put into a function are known as the domain. And the outputs that we get from a function are known as the range. So what is our range in this case? Our range is now 3 is less than or equal to. Here, we don't put x because x is an input that we are putting into the function. What do we put? Rather, we put f of x. So here, we have f of x, which is less than or equal to. The greatest number that can be there in this situation is when we add 1 to the greatest number here, which is 4. So 5 here. And we call this the range. There are different scenarios and you can be told to find the range in different situations, but this is just one of those situations. We want to find a function. And this function is such that if we put the range that we got from the function f of x, which was x plus 1, that function will map this function back onto the original numbers. Such a function is known as the inverse of our function. So what do we have here? We have 3, we have 4, and 5. And these were the range from another function. But we want a function that maps them back onto the input. Such a function like x minus 1, where is such a function that maps on whatever we took, and we are going to put it as an input, so it's going to be your x, right? And then if we are going to undo what we did by the other function, which means that we are going to be subtracting. So how do we subtract? Here we were adding 1 here. We were adding 1, so we subtract 1 here, and if we subtract 1 from these output values, we are going to see that we're going to get 2, 3, and 4. So what is this function that we just had here? This function was known as f of x. This function is known as the inverse of f of x, f inverse of x. So the inverse of a function is a function that undoes the effects of another function. And what we put into the inverse of the function are the outputs that we got from another function. What we are going to be getting out of another function, out of the inverse function, is what we had put earlier on into the original function. In other words, when you hear the books and the mathematicians saying, in technical language terms, it says the domain of the function is the range of its inverse, and the domain of the inverse is the range of the original function. In other words, what we put into a function is what we get out of its inverse. And what we get out of a function is what we put into the inverse. What we put into a function is what we get out of the inverse. What we get out of a function is what we put into an inverse. So that's the whole idea about functions and their inverses. Now, how do you find the inverse of a function? Now, sometimes you're told to find the domain of a given function. Now, the domain of a given function, if it is not given unto you, if you are told to find the domain, like in this case, the domain is the set of values of x for which the function's output is going to be defined. So, let's go over an example. Here we have f of x is equal to ln 2x plus 1. And we know that this ln is a logarithm. And logarithms do not take negative numbers. They don't take 0 as inputs, but rather their inputs are always positive. And how do we know something is positive? We know something is positive when it's greater than 0. So the input to our logarithm in this case is 2x plus 1. And 2x plus 1 is supposed to be greater than 0. And that's the range of values for which this input 2x plus 1 is greater than 0 is going to be our domain. So what do? We take the input 2x plus 1 is greater than 0. And this, if we solve it, it gives us the domain. So what are we going to do? This one goes to the other side. We are left with 2x is greater than negative 1. And what do we also get? The next step is we divide both sides by 2. 2 cancels 2, and now we have x is greater than a negative half. Now, this becomes the domain. So what is the domain there? The domain is x is greater than a negative half, and x is an element of real numbers. Now let's go over another example here. We also want to find the domain. Now this example, what are the values of x? Because we said that the domain is the set of values of x for which whatever the output of the function is going to be defined. Here